A few years ago, my friend Stefan Steinerberger came to me with a strange story. Stefan is a nerd. He loves Star Trek, he listens to a lot of classical music, and he is very nerdy about math. Actually, you could probably say he's a king among nerds. He's a math professor at the University of Washington. Stefan was teaching one day, writing down an intricate proof on the board and explaining it as he went along. And that's when he noticed that the proof sounded like music. Watch out, he told the students. This proof is like a really nice Schubert sonata. Schubert. Not Bach, not Beethoven or Brahms, not Scarlatti or Wagner. This proof was definitely Schubert, according to my friend. It was only later that Stefan learned that his students had no idea what he was talking about. This proof was like Schubert. Was their professor out of his mind? That was when Stefan brought his story to me. Who am I? I'm a cognitive scientist. I study how people process information and make sense of the world. One of the things I argue in my work is that the way that we evaluate explanations, deciding which narratives make the best sense of our experiences, that's a big part of what makes us smart, and it's a big part of what makes us human. So obviously, when Stefan told me that explanations of mathematical theorems seemed to him like music, that was extremely interesting to me. Extremely interesting, but not necessarily as surprising to me as it was to many of Stefan's students. And that's because I knew that mathematicians and scientists had been talking about the beauty of mathematics for millennia. In ancient Greece, Pythagoras declared that the mathematical precision of musical harmony meant that the universe was made of numbers. Cambridge mathematician G.H. Hardy said that there's no permanent place in the world for ugly mathematics. Some physicists like Albert Einstein seem to think that by pursuing beauty in our scientific theories, we're likely to arrive at the truth. And some scientists have even said that this search for beauty is more important than theories fitting experiments. Even the poets have weighed in on this. Keats wrote that beauty is truth, truth beauty, that is all you know on earth and all you need to know. So, mathematicians, scientists, and poets are all in agreement on this one point, that ideas can be beautiful. But I'm a cognitive scientist. I want to know why our minds would be set up to perceive beauty in math. This is really a bit puzzling. Here, it's useful to step back and ask why we find anything beautiful at all. Why do we like some paintings or faces more than others? The leading scientific theory is that we find things beautiful that are good for us in an evolutionary sense. They have survival or reproduction value. So, we like symmetrical faces because they're a sign of good genes, we like landscape paintings because they tend to depict scenes that are rich in resources, and we like things that are familiar because they're easier to understand and they're probably safe. So, the logical extension would be that we like certain ideas because they're easier to comprehend, they're more likely to be true, or they open up new avenues of understanding. In fact, some philosophers have made this exact argument. Why do we find simple explanations attractive? Well, simpler explanations usually require fewer assumptions, and they're usually pretty likely to be true. We seem to find simple explanations particularly satisfying, and maybe the reason we're set up to perceive them that way is because a love for simplicity turns out often to be a love for truth without our even realizing it. The psychologist Alison Gopnik has likened the feeling of satisfaction when we explain something to the experience of a sexual orgasm, both pleasures that motivate us. Just as the pleasure of an orgasm makes us likelier to produce children, so the argument goes, the pleasure of a satisfying explanation makes us likelier to produce understanding. A lot of these ideas might make sense, at least to me, but they haven't necessarily been tested scientifically. If they're right, you might think that not only professional mathematicians, but even math novices would be able to perceive beauty in explanations such as mathematical proofs. So this gave Stefan and I the idea to put our heads together and create an experiment. What we did was very simple. We wanted to recreate Stefan's experience in the classroom as well as we could. We gave hundreds of non-math experts 4 clips of classical music and 4 simple mathematical proofs, and we asked them to say how similar they thought that each piece of music was to each proof. It's actually so simple we can try it out right now. Here's a straightforward proof that was invented by German mathematician Carl Gauss when he was a child. Let's say you want to add up the numbers 1 to 100. There's an easy way to do this. First, imagine the numbers written out from left to right in one row, so 1, 2, 3, 4, and so on up to 100. Next, imagine a second row with the same numbers written out from right to left below, 100, 99, 98, etc. down to 1. Well, if you take the first number from each row, they'll add up to 101, 1 plus 100. If you take the second number from each row, it'll also add up to 101, 2 plus 99, and so on for all 100 columns. They all add up to 101. So, to add up the numbers, you just take the 100 columns, each equal to 101, and add them up. That's 10,100. Divide that by 2 since you have 2 rows, and you get 5,050. It's a pretty neat trick. You might even say it's beautiful. Now, what does it sound like? We gave participants in our studies 4 options, but we'll keep it to 2 for us now. Do you think this argument sounds more like this? Or does it sound more like this? Well, there is, of course, no objectively right or wrong answer to this question. We found something striking. People do not answer this question randomly. More people think this argument sounds like the first clip by Bach rather than the second clip by Shostakovich. This is especially true for people who have taken more math in school, but even people who have modest math training on average prefer the first clip. When we look across all the data, we can see that about 3/4 of the participants in the study made similarity judgments that are positively associated with the judgments made by the other participants. So even though most people's intuitions about these similarity judgments are relatively weak, they're still consistent enough across people that they are very, very unlikely to be random. And it turns out this isn't just about music. We did a similar experiment with landscape paintings. Do you think that the argument about summing the numbers 1 to 100 is more like the painting on the left or on the right? If you're like most people, the proof is more like the painting on the right, the Hay Wain by Constable, than like the painting on the left, the Harvey Andes by Church. But it's not that people think the painting on the right is more similar to everything. For other arguments, they actually think that the Andes painting on the left is a better match. When I tell most people, including other scientists, about these findings, they're very surprised. Even if people find these arguments beautiful, how is it possible for them to agree on something as ethereal as which piece of art or which piece of music resembles each proof? To find out, Stefan and I did one final experiment. We asked a new group of participants to think separately about each of the arguments and about each of the paintings that we used, and to rate them on a variety of different dimensions they thought might be common to the appreciation of math and art, like how simple, how intricate, and how profound each proof and each painting was. We found that people use very similar standards for deciding how beautiful proofs are and how beautiful paintings are. They rely heavily on how profound, how clear, and how elegant each argument and painting is. In fact, based on how participants in this last study rated each of the arguments and paintings, we could even build a statistical model to predict how similar the earlier group of participants thought that each painting and artwork was. In other words, when people come to agree about which proofs resemble which paintings, they seem to be basing that consensus on their judgments of factors such as profundity, clarity, and elegance. To me, this collaboration was scientifically very exciting. We provide some of the first evidence that people can experience not just sensory stimuli like faces and paintings as beautiful, but that we can experience ideas as beautiful. This research presents a fresh take on a discussion that's been going on for thousands of years about the beauty of mathematics. It turns out that's not just in the eye of the beholder, but even non-experts can agree on what mathematics is beautiful and how it's beautiful. But there's a second lesson here, and that's about the fruits of collaborating across different disciplines. Stefan is a math nerd, I'm a cognitive science geek, but together we managed to discover something that probably would not have been possible without ideas that each of us had, coming from our very different backgrounds. We built on insights from science, from math, from philosophy, and even from the poets to discover something new. I like to think that there's beauty in that. Thank you.